All right, y'all, can you believe we're almost done with Module 3? So this is Lesson 22. It is Proofs on the Coordinate Grid. And this should be starting on page 26 in your packet. So let's go ahead and work our do now. You might want to pause the video and then come back and make sure you did it correctly. So it says find the length of MP given that M is at 4, -2. 1, 2, 3, 4, 1, 2. So there's M. Come on, work. And P is at -1, 3. So -1, 3, 1, 2, 3 is here. Of course, you're going to want to label this P, and this is M. And it says find the distance, find the length of that. And so if you remember from Unit 1, so we're bringing back Unit 1, you're going to have to draw a right triangle. And this is a length of 1, 2, 3, 4, 5. This is a length of 1, 2, 3, 4, 5. So to find the length, I would do 5 squared plus 5 squared, which is the square root of 50. Because 25 plus 25 is 50, and then the last step is to take the square root. So I can predict that this side right here is the square root of 50. Okay, secondly, it says, what quadrant would the midpoint of NP lie in? Well, let's go ahead and label our quadrants. Remember, they go counterclockwise. So this is 1, 2, 3, and there's 4. So if I'm looking at the middle, I'm thinking the middle looks to be about right here. So I'm going to say it's in quadrant 1. And now I'm going to calculate midpoint. So I'm going to take my x's. So 4 plus -1 divided by 2. And then I'm going to do -2 plus 3 and divide by 2. And when I do this, I get, this is 1.5. And this is 0.5. And so I was correct in assuming that it's in quadrant 1. It's 1.5 and 1 is like right up. My pen's a little bit off. All right, lovely. Quickly review. Distance formula, and then the other one we learned is that you can use the Pythagorean theorem, which would be c squared equals a squared plus b squared, or you can type it into the calculator. Midpoint formula, x plus x divided by 2, y plus y divided by 2. And then please remember that the slope formula, and the symbol for slope is m, and it's y2 minus y1 divided by x2 minus x1. You might want to write this down in your notes. And then these are not in your notes, but a quick review. Today we're going to be talking about a coordinate proof. And basically it's a proof that places a geometric figure on the coordinate plane. And then we're going to be using distance formula, midpoint formula, and slope formula to complete the proof, which is why we have these. And don't forget, once again, for distance formula, you can use c squared equals a squared plus b squared. If you have a right triangle, this will always be c. And then midpoint, you add the two coordinates, divide by 2, and then your slope formula, remember, is the difference, the ratio of the change in y, which is y2 minus y1, over the change in x. Okay, so I'm going to model a couple of problems for you, and then you do have group activity. If you are not working as a part of a group, then you'll have to do the entire thing independently. So a model on page 27, we want to prove that the line segment CD with endpoints at 2, 2, and D is at 0, 0, is perpendicular, is a perpendicular bisector. So please remember perpendicular, the symbol for perpendicular is this. We should be thinking 90 degrees, and bisector we should be thinking cut in half. So we're going to be performing a 90-degree segment, and it's going to be cut in half. So let's go ahead and work this out. This is page 27 in your packet. So the first thing you're going to do is you are going to plot the points. So 2, 2 is here, and 0, 0 is here. So this is C and D, and then I'm going to plot the points for A, which is at 2, 0. It's A, and B is at 0, 2. So I want to know, do those make a 90-degree angle? Well, it surely looks like they do. All right, so the first thing we're going to do is we're going to go ahead and find the slope of CD. So let's remember that coordinates are here. So I'm looking at C is at 2, 2. Oh, she said 2, 2. And D is at 0, 0. So remember the slope formula is y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. So this is going to be 0 minus 2 over 0 minus 2. And that's negative 2 over negative 2. So that is a slope of positive 1. Because a negative divided by a negative is a positive. All right, now I got to find the slope of AB. So A is at 2, 0, and B is at 0, 2. Okay, so this is A. So again, I'm going to do 2 minus 0, because this is y2, y1, and then it'll be 0 minus 2. Okay, so 2 minus 0 is 2. 0 minus 2 is negative 2, so I get negative 1. And what you should notice, for them to be perpendicular, so perpendicular should have opposite, reciprocal, and you should remember this from Unit 1, slopes. And so you've got 1 and negative 1, so check. That works out. They are perpendicular slopes. All right, so the next thing we have to check is to determine if we're looking at midpoint, okay? So the midpoint of C is going to be, again, the points are 2, 2, and 0, 0. So x plus x, 2 plus 0 divided by 2 is 1. And over here I've got 2 plus 0 divided by 2, which is 1. So the coordinate should be at 1, 1, which is right. I think I drew my red line a little wrong. So now I'm going to find, then of course you read it as a coordinate point. Now I'm going to do the same thing for AB. Oh, I'll switch up my colors. How about I do green? And I got A is at 2, 0, and B is at 0, 2. So these are my x's. 2 plus 0 divided by 2 is 1. And 0 plus 2 divided by 2 is 1. And since I've got the same midpoint here, I can check this off that, yes, in fact, I have cut it in half and I have a perpendicular bisector. And that's as far as I'd like you to go. We're not going to do statements and reasons for this at this time. We'll do it at another time. All right. Let's move forward. Here is model example number 2. All right, and we're going to call this triangles. We're going to prove that these two triangles are isosceles. So let's think back to what we know about an isosceles triangle. Okay, so we've got two sides that are congruent, and these are our base angles. So we know our base angles are congruent, and this is what we call our vertex angle. Okay, so this is what we're trying to prove, that we've got two sides that are congruent, and then we've got two angles that are congruent. So we're going to do this by looking on page 28. And let's go ahead and get started with this model problem. Hopefully I can do this in one video. Let's see. All right, so we're going to find, first we have to find the distance from A to B, and I want to put this on a coordinate graph. So hold up for 1 second. I just included my coordinate graph so I can go ahead and graph these points. So first I'm going to graph point A, which is at 1, 7. Come on. There we go. There's A. B is at 9, 3. And C is at 3, 1, which is right here. Okay, so now I've got this triangle, and from what it looks like, it appears that it might be isosceles. I don't know for sure, but I'm going to test it out. So the first thing I got to do is find the distance from A to B. So I'm going to draw my right triangle. This is 1, 2, 3, 4. 1. This is 8. So this would be 4 squared plus 8 squared. which is 36 plus 61, which equals 80. So this is the square root of 80. So right here is the square root of 80. All right. Now I'm going to test the next side. I'm going to find the length from B to C. So I'm going to look from here to here. So this has a length of 2, and this has a length of 6. So this is 6 squared plus 2 squared, which is 36 plus 4, which is the square root of 40. Well, clearly, I know right now that these two sides are not congruent to each other. So let's move on and look from A to C. So I'm going to look here, come straight down from here. This was at 7, 1. So this has a distance of 2, 1, 2, 3, 4, 5, 6. And so what I notice is that from A to C, I've got 6 squared plus 2 squared, which is also the square root of 40. So this side is the square root of 40, and this right here is the square root of 40. So I know these two sides are congruent. Therefore, I can prove that these two triangles are, this triangle, excuse me, is isosceles. So the first thing I'm going to do is the distance of the distance of AC equals the square root of 40, and the distance of BC equals the square root of 40. And I did this by doing the distance formula, but I actually used C squared equals A squared plus B squared. Okay, then the third thing I can say is that the square root of 40 equals the square root of 40. Okay, and this would be definition of congruence. So those of you that wanted to know when to use definition of congruence, this would be a perfect opportunity. And then the fourth thing is that it says prove ABC is isosceles. Well, I'm going to write here that triangle ABC is isosceles, and I know this by the definition of isosceles triangles. Okay, so now that we've completed this proof, you're going to need to write an email to Alex explaining how you completed this proof. You're going to need at least 3 to 4 sentences to write all the steps. So you'll need an intro and conclusion as well. So you're looking at 5 to 6 sentences. And make sure you include the definition of isosceles in your explanation and that you use TIDE as a guide. You need to do this on a separate sheet of paper. This is on separate. And you're going to need to turn it into separate paper. Okay? When you're done with your TIDE paragraph, then you can use these 2 model problems. You're going to need to see me, and I've got some wheels for you to work on. Normally we're going to do this as a group, but because you missed the opportunity to work with your group, you're going to do it independently. So you always start with number 1 right here, and you're going to work through and do exactly what it says. So the coordinate points that you're going to be plotting are here, C, D, and A, B. Okay? Draw your lines. Then you're going to calculate the slope here. Move on to step 2. Then you're going to find the midpoint. And then 4, you're going to write a 1 to 2 sentence conclusion. Are they perpendicular bisectors? And how do you know? All right. When you're done with that, you're going to move on to the next wheel. And here you're going to try to prove whether the following triangle is isosceles. Okay? So first you're going to plot and label the triangle here. Then you're going to find the distance of each side, use the Pythagorean theorem or distance formula, and then you're going to determine whether triangle HOT is isosceles. And then lastly, you'll conclude with triangle SUN. Okay? So you've got quite a bit to work on independently. When you're done, please turn everything